Hi, I'm Craig. Today I'm going to talk about laziness and functional programming in Ruby. If you want to add me, I'm on Twitter and Ruby Social infrequently. Links up at the top. Short URL on the slides if you want to read along, if you want to look at them later. You can hit P to see the presenter notes that I'm looking at. They've got some extra links to resources and some things I don't have time to cover. And I took that picture this morning from the hotel. Much better than the AI picture. Who knows who Larry Wall is? All right. Larry Wall is the creator of Perl and the language formerly known as Perl 6, Raku. So this is a quote from him. The three chief virtues of a programmer are laziness, impatience, and hubris. I identify with Larry's description. My wife's therapist says I'm a sloth, and I've embraced that label. So we have a few sloths around the house. So let's start with a definition of laziness. My definition is delaying computation until the result of the computation is needed. So I often see code like this in a Rails controller, and this is the kind of code that prompted this talk. Why do we need to set the current user account before everything else? Well, we don't. Rails requests are synchronous. There is no ahead of time. You only need to compute things before they're used, and I'm going to argue that you should compute things right before they're used. So this code is more lazy. It waits to do the computation until it's needed. We could also compute the value in the initializer, especially if it's always needed. We're still worrying about the thing before we need it, and I contend that this mindset is harmful. It's a holdover from procedural code. At least in this case, though, we're at least thinking of the current account as a property of that object instead of an action that needs to be done. The original code did have one advantage, and it only computed the value once, but that's easily solved with memorization. So what is this line telling us when we read it? It says we need to set the current account before anything else, but it's a lie. We can forget about the current account until we need to use it, actually. So, and if we named it well, we probably never really need to look at how it's implemented. So controller before filters are still useful, but they need to be used as a filter and for interrupting a request before we actually start doing anything. Usually that's going to be authentication or authorization. Note that instance variables in Rails controllers also get copied to the view in some weird way, but I recommend against that too. We can pass the locals to render. We can label them as helper methods. I prefer the decent exposure gem, which is more declarative in what we're passing on from the controllers to the views. So let's get to memorization a little deeper. Before we memorize, we should make sure that it makes sense to memorize something. And to memorize something, we want it to be idempotent. We want it to produce the same result when it's called multiple times with the same arguments. That's idempotency. And we want to make sure it's pure. It doesn't have any side effects. So in the example here, 2 times 3 is always going to give 6, so it's idempotent. And there's no side effects. But if we call time.now, that's not idempotent. It gives us a different result every time. And it's actually accessing the outside world. And if we're doing a puts or a gets, we're also talking to the outside world. So we have an idiom in Ruby for memorization. So memorization caches the result of the computation so we don't have to compute it again. So the or equals operator assigns a variable, assigns to the variable if the variable is not already nil or false. Otherwise, it assigns the value on the right-hand side. Undefined variables, if you remember, start as nil. So the basic Ruby memorization idiom doesn't handle nil or false. That's rarely a concern. We rarely have something that's true, false, or some other value. And nil is usually the failure. It's usually very quick, and it might even tell us that we should try again. It's also not thread safe. Who here does anything that needs to be thread safe? All right. Oh, that's a few more than that. That's good. So here's a longer version of memorization. It's a bit idiomatic. that does handle nil and false, and it's also good if your method is more than one line long. So it uses Ruby's defined construct, which is a long story in itself, but it does the trick right here. So Rails used to come with the memorize gem built in, but it was deprecated way back in Rails 3.2. You could define your function and then say memorize this function. So defining a function actually returns the name of that method as a symbol, and we can use that as the argument to memorize, so we can actually shorten it here. And here I actually use the Ruby 3.0 short method definition syntax, and so we've got one line there just to define that simple method. So to me, this reminds me of type qualifiers or attributes in C, C++, if you are familiar with those. Things like const or static or extern or volatile. So I like the Memorize gem, and so Memoist is an extraction of that lets us keep using it. And it even works for methods to take arguments, and the idiom for that is a little bit more complex. It's in my notes here if you want to take a look. This is possibly out of date. It hasn't been updated for a while, and it hasn't been tested on more recent Rubies. Memorizable is another popular gem written from scratch. It's written by Dan Cubb, who's I consider to be a leader in the functional programming branch of the Ruby community. It's more up to date, and it's mutation tested. That verifies that all possible code paths have been covered by tests, which is pretty amazing, actually. Dan seems to do that with all his code, even Rails code, and that's impressive. And it ensures all the code that's actually there is necessary. Ruby 3.2 introduced a data class. It's much like a struct, except it's immutable, and there's no setters and no behaviors. So we can define a data class with the define and the list of fields that go into that data class. So here we create a class called person that has a name and an age. And we can create a new instance with new, just passing the fields values by name. Pretty standard there. And we can subclass that data class. This is my preferred style because it's consistent. I can see that it's a class just like any other class. It starts with the word class. This does have one major downside. There's actually an anonymous class between the data class that we define there and person class. Pretty minor, probably not going to bother anybody. You'll only see it if you look at person.ancestors there. And we can override the initializer if it's a class. In this example, we're going to normalize the name and age because we want names to be capitalized and ages to be integers, right? Or we can pass a block to data define and add and override methods. There's a minor downside to this that person is not defined until you're outside of that do. But hardly anybody uses it. Usually we would use self instead of person there. The bigger downside is forgetting that do. Unless you're in an Elixir program where you're used to forgetting the do's and adding the do's and figuring it out. So data class also allows us to use square brackets instead of new. I find this is kind of maybe an upside because value objects are visibly distinct from mutable objects in this case. And it's immutable. Why don't we make it a constant then, right? So Domain-Driven Design is a great book. It's one of my top 10 programming books by Eric Evans. It tells us how to divide up code cleanly. And he divides objects into 3 different categories. We've got value objects, which have immutable state, no behavior. Entities, which have identity, like the ship of Theseus. And they have mutable state. And then we have service objects, the things that sort of coordinate the other things. And if you're used to an actor model, that would be an actor. Value objects are easier to reason about because they don't have any state changes, they don't have any side effects, they're easier to test. We don't need to set up a state. We don't need to check any state changes. We just give an input, get an output. So what is this behavior Behavior to me is changing an object's state, having a side effect, or interacting somehow with the outside world. And methods included in a value object should just transform the inputs, which are provided when you new up the object, into outputs, and they should be pure functions. Which brings us to functional programming. Is Ruby object-oriented or is it functional? It's both, right? So Ruby's functional programming is most commonly used with enumerables. So we've got an array or a hash and a range. Map is a functional concept, and it just transforms the data. But Ruby is also a procedural language. Here, the each indicates that we have some procedural code because its side effects are its only reason for being. Each doesn't actually return anything. So we have to mutate Y. So both of these return the same results, right? The second example doesn't mutate any state. Doesn't mutate anything, really. So we don't have to wonder if something else is modifying Y. We don't have to worry about side effects, so we can reason about this code more efficiently, more easily. Ruby has quite a few methods that mutate data in place. We can still mutate contents of arrays and hashes. We do that a lot. We tend to mutate active record objects a lot. But note that we don't use these very much anymore. We don't do map bang and sort bang and shove it back into X. By the way, Phoenix Elixir doesn't mutate their domain objects. They actually send a change request to the database instead of like, hey, here's the change object, figure it out yourself. So that provides immutability benefits to almost all your domain objects. So we've had lazy enumerator since Ruby 2.0. This is sort of the traditional definition of lazy evaluation. And this is a little different than my earlier definition, and it's focused more on expressions. So the top code here will run forever. It will never finish the select and get to the first. The bottom code will stop after returning the first 5 odd numbers. The lazy returns an enumerator lazy object. It's a special kind of enumerator where it collects the blocks and doesn't run them until you need a result. So I was looking for examples, and all the examples I could find online were using range, and I'm like, oh man, I need to find an example. I wonder if active record can be lazy. And I'm like, oh, active record is already lazy in its own way. So it uses something underneath called active relation, AREL. And because it doesn't actually execute the query until you ask for the results. So here, until you call the 2A, it doesn't actually do anything. It just collects up all the steps it needs to. So it uses a relational algebra using the builder pattern to build up the query. So all returns a relation, and then where adds a new relation onto that. Order returns a new relation that's built on those two. And then 2A takes that query that's built up and runs it and returns the result as an array. So object-oriented program tells us to tell, don't ask. An object should contain everything it needs to do something. We just tell it to do that thing. We don't ask it for information and do something with that information. So all procedural code can actually be seen as telling. We tell the computer how to do something. So here, the system monitoring checks the temperature and sends an alarm when necessary. We don't really want to do that in the other way. We don't want to create a system monitoring and then have someone else know, well, what's the temperature that we should monitor and what should we do when it happens? But you can't tell an immutable object to do anything. You can't tell it to change itself. You don't want it to tell it to interact with the outside world. But you can ask it to give you a new object, and you can persist that new object if you want. Here, I didn't have a first name. I gave it a first name and a last name, and I have a method called full name that just takes those inputs and creates a separate output that's always the same. And I might have a spouse and be able to get the full name from that. And if I want to change my name, I create a new object, and maybe I persist that object. I don't actually mutate the Craig constant itself. So who's seen this talk, Boundaries by Gary Bernhardt? Great talk. I put it on a yearly rotation. So he talks about a functional core and an imperative shell. So basically, your code in the small should be functional. And then he calls it an imperative shell around that which interacts with the outside world. So do as much as you can with functional objects, functional data structures, and then you can do that persistence layer in a layer above. So in my abstract, I talked about better styles, better code, but what does it mean for code and styles to be better? We often talk about readability, but it's really about whether it's easy to understand and to maintain. How easily can someone understand the code and make changes to that code? But what we really care is how easy is it to change our code? Because our code is always changing, it's always evolving. I'm reminded about this quote from Kent Beck: make the change easy, then make the easy change. Everything we're doing when we're coding should be making the change easy. There's also a social aspect to what's better, what we consider better. For example, we don't use for loops in Ruby anymore, right? We use each or we use map. So I use this in the code above, and you notice I put the private right next to the definition to make it obvious. Instead of having a block of, well, all the private ones are down here, all the public ones are up there, I can move this code without caring about, oh, I put it in the wrong spot. Who's put it in the wrong spot before? I've put a public thing in private and I put a private thing in public. Like, why don't we just put it right there? It makes it easier for us. Warning, Rubocop does not like this though. Short methods are more readable. So I tend to refactor relentlessly, try to get to one-line methods like this. So I'm trying to optimize my style for readability and error avoidance. So thinking back to Larry Wall's quote, I was reminded by this quote from the Agile Manifesto: simplicity, the art of maximizing the amount of work not done, is essential. So I love TDD. I like this thing called README-driven development. TDD has these offshoots, BDD and acceptance test-driven development. There's even things called data-driven and model-driven development, and probably worth looking into. And I thought, well, maybe laziness-driven development should be a thing. So I Googled to see if it already existed. And I found this lazymanifesto.org, the manifesto for lazy product development. And you know, he talks about simplicity and quality. I like that he talks about keeping slack. That ensures that we can handle unexpected events. If your team is all full of work and you all of a sudden surprise them with new work, all that other work, all your plans are going to go to hell, right? It's just, slack time is actually important. And you know, you can use that slack time to experiment or to add work that we didn't expect. I like his focus on simplicity and quality. So some of the principles here are the Lazy Manifesto. Work hard only if it makes work easier and safer. Doing nothing is always an option. I love that one. Minimize backlog items, but keep the value of the backlog. Increasing velocity is not always a good thing. Eliminate tasks that generate no value. Rearrange tasks to find the problems early. So if you've done a lot of work and it turns out that you've gone down the wrong way, it would have been better to figure that out earlier, right? Simplify all tasks, automation, find lazier ways. Capabilities over capacities. What are we capable of doing? Not what do we have room to do? And get help from others. So I thought, well, that's not quite what I'm looking for, but it's pretty close. So here's my take. Let's prefer outcomes versus output and how much work we've done. Let's focus on business value versus productivity. And let's work on effectiveness versus efficiency. We can be very efficient at building the wrong thing, but what's the point of that? So one of the key indicators that you're probably doing it right is happy developers, by the way. We want to do less work, but still make the customers happy. So Lean Kanban talks about waste. It tells us to eliminate waste. Where do we find waste? Lean says that all work in progress is waste, because if you need to deliver today, we can't use that. It's still work in progress. Every time we change tasks, we have to go through a context switch in our mental state. There's this concept of maker time versus manager time. Makers need long blocks of time to get into flow, to get all that context in their head. Managers have short blocks of time to answer questions. If you try to fit maker time into manager time, it's not going to work well. Can we agree most meetings are a waste of time? My suggestion is collaboration and work on things instead of talking about things. Unused features probably cost more time, more than bugs. We have the developer time, but we also have the carrying cost. Like every time you run CI, it has to test that stuff that you're not even using. I had an example where the CEO, we spent months on this feature. No users ever used it. We could tell no users were ever going to use it. It's what he wanted. Unnecessary code testing and documentation. I will say testing is usually necessary for automation and for documentation purposes, because it documents what the code is supposed to do. But occasionally we'll have some tests that really aren't useful. It's okay to throw those away. When we think long-term, we make better decisions, right? We often do the wrong things. We don't take this time to understand our problems. We build the wrong thing. We just don't do a good job. So take the time to do things right, do them well. Collaboration and pair programming reduce waste. We don't spend that time waiting for answers. We got more eyes to catch mistakes. We're building on each other's ideas. Automation. My role in automation is automate when the cost of not doing so outweighs the cost of doing it. Same for documentation, testing, abstraction. Keep your Yagni in mind. You ain't gonna need it. Stick with the rule of 3. If you haven't done it 3 times, probably not time to automate yet. Think about the next person who has to read this code. Code is a liability. It has to be read and maintained and updated. Optimize for the reader's time, which is likely future you. Always be kind to future you. I know past me was a jerk. His code is terrible. But save time by making sure future you can understand it. Make sure to document why you did things the way you are. I can see what the code does, but why is it doing that way? What were the constraints I was thinking of? Code is not just a one-time cost. It has to be tested, maintained, readable. So we want to minimize the amount of code we write and maintain. We can use libraries and frameworks to offload a lot of that, but those have some cost too. Updating, security issues. Better abstractions are a great way to write less code and code that's easier to understand. Don't be lazy in our thinking. Be lazy in our doing. So some takeaways. Functional core versus imperative shell. I think that's probably where the industry is going, where it needs to go at least. We need to think in the long term, more the short term. Remember that code is always changing, and we need to be adapting to those changes. Delay work when necessary, and our real job is to learn. And I'm reminded of Lean's last responsible moment. Make decisions at the last responsible moment. Add the code at the last responsible moment. So that's it. I've got some resources here. Gary Barnhart's Boundaries talk is probably where you should follow up next. Documentation on the data class and lazy enumerators, domain-driven design, and that lazy manifesto. I am looking for a job as a principal software engineer. I just wrapped up a short-term contract, and I'm looking for a new good opportunity as a player coach. And I've got a lot of experience. I am very easy to find on the internet if you can spell my name. Thank you.